Centre of gravity. The centre of gravity of a body is that point through which the sum of the forces of all masses of the body are considered to act, and is situated on the longitudinal axis, acting parallel to the gravity vector both in the air and on the ground. If the C of G is forward of the centre of lift, there is a nose-heavy moment. If the C of G is aft of the centre of lift, there is a tail-heavy moment. Balance arm. Force A, which is a product of arm and the force, is balanced with force B, which is a product of the arm and the force. This pivots around a pivot point or fulcrum. Centre of gravity. Pitching moments are counteracted by moving the elevator to maintain level flight. This is normally achieved by trimming the elevator. Trimming may result in an increase in profile drag, reducing efficiency and range because of higher fuel consumption to overcome the additional drag by increasing the power setting. If the CG range is large, elevator trimming could result in reduced pitch control. Effects of CG position. CG at the forward limit. Range is decreased, pitch is stable, elevator pitch is nose up, reduced. There's more trim drag, the stalling speed is increased, and fuel consumption is increased. With CG at the aft limit, range is increased, pitch is unstable, elevator pitch nose down is reduced, there's low trim drag, stalling speed is decreased, and fuel consumption is decreased. Effect of mass on the CG. At higher mass, pitch control forces required are greater, and the CG forward limit is moved rearwards. As the aeroplane mass reduces, the CG range is increased by moving the forward limit forwards. Determination of CG. CG limits. The range of movement of the CG fore and aft of a datum that does not put the airplane in an unsafe condition. Moment or balance arm. The distance from the datum to the centre of gravity of a mass is known as the moment arm. Datum. A point chosen on the longitudinal axis of an aeroplane, but not necessarily between the nose and the tail of the aircraft. These definitions may be found in Cap 696. Basic empty mass. An aeroplane must be weighed routinely to ascertain its basic empty mass prior to initial entry into service and every 4 years in a hangar, with the air conditioning switched off, a hangar doors closed, or when new equipment has been added to the aircraft. If fleet masses are used, then the aircraft is weighed every 9 years. A minimum of 3 points must be used to ascertain the basic empty mass of an aircraft.